Hi parents and students, this is a short video to remind us of how we can use arrays to help us with our division. If I have my example 153 divided by equal groups of 3, I'm looking for how many in each group. I have my students start off labeling their dividend, their divisor, and their quotient. My dividend gets a large D, my divisor gets a small d because my dividend is my larger number and my divisor is my smaller groups. And I'm always looking for how many in each group. So using my base 10 blocks, I have 153. This would be a model of what that number would look like with our base 10 blocks. Now I can't share my base 10 blocks like this. I can't make 3 groups of this 100. So my students know that they need to take this 100 and they need to break it into its equal parts of 10s. Now that I have my equal parts of 10s, I have the same amount. Now I can take this number and divide it into its equal groups of 3. And I'm going to do that with an array. And since it's a division array, I want to show that it's a division array because we use arrays for both division and multiplication. Now, I know that I have 3 groups because I learned that from my divisor. 1, 2, and 3 groups. I'm going to take my 15 rods. Where did I get that 15 rods? Well, I got it from that 100, the flat that I exchanged for my 10s and my 5 that I already had. So I'm going to take my 15 rods and I'm going to share them as equally as possible until I get to the point where I can no longer share equally. Oops. So I'm going to do that and I'm going to have to do it, not side by side. So I'm going to go ahead and share equally, one at a time. Now, with this problem, it works out pretty easily where we can see that each of our 15 rods divides very nicely into our 3 groups. That leaves us with 5 rods. Now, I still have my 3 units. Since my 3 units are already broken into their smallest form, we can just go ahead and nicely share each of those units. This would be a picture model of what a division using an array would look like. Now, with the base 10 blocks, it makes it pretty simple because you can actually share those base 10 blocks. What the students will have to do is they will have to imagine those base 10 blocks and they will have to actually draw out what they are using. So instead of having the base 10 blocks, they do not know how many in each group. They're looking for their number. That's where this number is going to come from. We do know that we have 153. Now, if I take that, I can't share that one. So again, I'm going to think to myself, well, I'm going to exchange it for 15 of them. I can do 10, 20, 30. And I can subtract out that 30. Now, the students who know their multiplication facts, they wouldn't need to go subtract as soon, and then they could continue adding those 10s in a quicker manner. So, for example, if you already knew your multiplication facts, you would know, well, 3 can go into 15 5 times, and you would go ahead and share your 5 with your group, and then you could just subtract it out all at one time. It depends on the kids. It's at their level. So now that I've subtracted all 15, so I'll go ahead and get rid of what I went ahead and added. I added another 12, which is technically 120 because each of these is worth 10. That leaves me with my 3. Now I have to go and share those 3. This is what they are going to be expected to do to be able to draw. I always have them go ahead and number 10, 20, 30, 40, 51. So that gives them a total of 51. And they would need to count each group and see that each group is an equal group of 51. Now, they can go ahead and put their answer here, but they're not allowed to leave that answer unless they use their inverse operation of multiplication to check. So by using their inverse operation, they would take their 51, they would multiply it by their groups of 3, and they should come up with their same answer that they started with. So using our knowledge of our multiplication facts, I'm going to use the distributive property. I know that 3 times 50 is 150, or 3 times 5 is 15. Add my 0. And then 3 times 1 is 3. I put those two partial products together. I get 153, which was my starting number. So I do know that 51 is the answer to this problem.